All right, let's get started. So thanks everyone for making it to the end of the Data Nerds Day and joining me with my session. I'm Hannah Troisi, and I'm a developer relations engineer at Pixie. Before we get started today, I just have to quickly say that we may get into some roadmap-specific questions or topics at some point, so I just have to have this safe harbor slide to say that anything on the roadmap that I discussed could potentially change in the future. So in this section, I'm going to provide an overview of Pixie, which is part of our Kubernetes observability solution at New Relic. And then I'll show some live demos, including how you can install it, how you can debug with it. And we're going to write a Pixel script. And that's where we're going to spend most of our time. This is the advanced Pixie session. So hopefully you either watched the other 2 Pixie sessions earlier today, or you can check out the recordings later. And I'll mention these recordings by name at the end of the talk. And I think a link will be sent to you at the end of this talk as well, so that you can check those out as well. Okay, so intro to Pixie. So Pixie is an observability tool for Kubernetes applications. And when the Pixie team set out to build this tool, they wanted to build something that would just take a few minutes to install. It wouldn't require any manual implementation instrumentation. And then after installing, you'd immediately get visibility into your system. And not only your system, but like application level metrics as well. So the main features of Pixie are that it has auto telemetry using eBPF. So using eBPF, Pixie automatically collects telemetry data such as full body requests, resource and network metrics, application profiles, and more. Another feature of Pixie is that it's 100% scriptable and API driven. So we'll discuss Pixie's Pixel query language later, but it can be used across Pixie's UI, CLI, and client APIs. Pixie provides a set of community scripts for common use cases, and we'll see those later as well. And then the last feature of Pixie is that the telemetry data lives in memory in your cluster. So you'll get the copy to these slides later, so you can check out the links below. And finally, New Relic acquired Pixie in December of 2020. And then they contributed the Pixie project to the CNCF in June of 2021. So the Pixie project is entirely open source, and we welcome any contributions in terms of Pixel scripts or anything else you'd be interested in contributing. So New Relic's Pixie integration adds long-term storage onto Pixie. It allows you to use New Relic's alerting, dashboarding, and workloads as well. And a previous talk discussed more about how you can use Pixie natively in New Relic. This talk is going to just discuss Pixie scripts. So again, I'll send the link out to that talk later. Okay, so a lot of people are curious about how Pixie works. So Pixie uses eBPF to drive its data collection, or most of it. This means that, again, you don't have to use any instrumentation to get Pixie data. So the main feature that people love about Pixie is the automatic tracing of protocol messages. And the way this happens is that when Pixie is deployed to the nodes in your cluster, it deploys eBPF kernel probes, K-probes, that are set up to trigger on Linux syscalls used for networking, like connect, send, receive, and close. So when your application makes these network-related syscalls, Pixie's eBPF probes snoop the data and send it back to the Pixie Edge module. In the PEM, the Pixie Edge module, the data is parsed according to the detected protocol and stored in tables for querying. So the PEM is deployed as a single daemon set on each node. And again, that's using eBPF to collect the data. So Pixie also can trace TLS connections. So this tracing works in a similar way as the basic protocol tracing, with one main difference. Instead of snooping the Linux send and receive syscalls and related syscalls, we're setting up U probes on the TLS library's API. So this allows us to capture the data before it's encrypted, because if we were capturing it at the Linux syscall level, it would already be encrypted. So we currently support OpenSSL and GoTLS encryption libraries, but we have more planned in the future. And again, that's an area we're happy to accept contributions for. So what can you see with Pixie? So Pixie automatically collects protocol traces, so full body requests between the pods in your application. And this is the list of all the protocols we currently support, and we're adding more all the time. We also collect resource metrics, so CPU, memory, and IO metrics. We collect network metrics, and we also have a continuous application profile running. So we sample stack traces from your application, and this will help you identify application performance bottlenecks. That is currently supported for compiled languages, and I believe Java will be added soon. So before you install Pixie, you should make sure that your cluster is supported and that the protocol you're interested in tracing is also supported. So I'll just pass through this, but you can check out the docs later for these. Okay, so demos. All right. Okay, so we're actually going to use a lab account, which has Pixie already installed. Actually, let me go back to that. Or it's in the chat. The details are in the chat. So you don't need to install Pixie on your own cluster right now. You can use that lab account, but I'll just show you how you would go about installing Pixie if you wanted to add it. So from your main New Relic 1 page, you'd click Add More Data in the top right-hand corner. Guided install. Select the account. And then this is part of the Kubernetes Observability solution. Then you can click Begin Installation, and then just confirm your account and cluster name, and you can leave the default namespace. And then here you can see Pixie, which is the newest addition to New Relic's Helm chart bundle. So make sure this is clicked, which should be by default. And when you press continue, you'll get the Helm chart or the Helm install command. And once you press continue, it'll start listening for data from Pixie. So that's how you install Pixie, but you don't actually need to install it right now because in the chat, I've listed the lab support account, and just someone noticed that you need to like refresh that to be able to get, to be able to see the live debugging tab, which I'll show you in a minute. So if you aren't seeing this live debugging with Pixie tab, try refreshing. I'm not exactly sure. I just noticed this in a previous talk. Okay, so here we are at New Relic's Kubernetes Cluster Explorer, and this gives you basically a high-level cluster overview. So you can see that we have 2 nodes on here, and you can see resource consumption of these nodes. And there's a slide out showing memory, storage, and CPU usage. We can see the pods that are running in this cluster, and Pixie is picking up 21 services. And so it just gives a high-level overview of what's happening in your cluster. If you scroll down, you can search for a specific pod or container or node. So the native New Relic Kubernetes Explorer does a really good job of showing the state of your Kubernetes resources and deployments, like whether they're alerting or running or whatever. Pixie does a really good job of showing relationships. So if we pop over to this live debugging tab, this is showing Pixie's native UI. So everything in Pixie is driven by scripts. So you can see we've got the PX cluster script up here. And if you hover over it, that will give you a description of this script. I've also included on the slides the list of all of the Pixel scripts. This is in Pixie's open source GitHub repo. So if you want to look at an overview of all of the scripts at once, here they are. So I'll pop back over here. So this cluster script, what it's showing us is a service map of overview of the connectivity between all the pods and services. So if we zoom in, we can see I've got a stock shop demo application installed. Oh, here it is. And here's the load test, and it's hitting the front end. And the front end is talking to a bunch of services like the catalog and other services. So we can color that by, it is currently colored by error rate, but we can also color it by latency. And then this script also shows a list of the nodes it's detected and namespaces, as well as the services. And in this services table, you can see that we've got all the golden metrics like latency, throughput, and error rate. And if you expand the latency column, you can click to get P50, P90, and P99 values. So this is an overview of how a single script in Pixie works. We've created Pixie so that you can easily navigate between scripts. So if you click on or hover over any Kubernetes resource in any Pixie script, it will take you to a script of an overview of that resource. So here I'm clicking on a node. We'll see what's on this node. Okay, so here is so you can see it's taken us to the px node script, which gives us an overview of the node with the node script argument already filled in. So here we've got a list of the pods. We can see the CPU usage over time, the bytes read and written, network traffic, memory size. And if you scroll all the way to the bottom, we have a flame graph for this node. So this is a representation, or basically you can see which functions are taking the most time. So the dark blue is like Kubernetes metadata. So you can see that the sock shop app is taking 5% of our CPU usage. The blue is application functions and the green is kernel. All right, so this is like a high-level overview of how you can use Pixie. Hop back to the slides. So for more information, you can check out the open source tutorials, which look like this. So we've got one for network monitoring, infrastructure health, service performance, database query profiling, request tracing, and continuous application profiling. And you can also check out those scripts I mentioned before in a list in our repo. Okay, so let's talk a little bit more about Pixel scripts. And feel free to ask questions if you have any questions in our chat. Okay, so everything in Pixie is powered by a Pixel script. And Pixel scripts are written using the Pixie language, which is a domain-specific language for working with machine data in the Python dialect. It's almost a complete subset of pandas. Like Python, Pixel is implicitly and strongly typed and supports high-level data types and functions. Unlike Python, Pixel is a data flow language that allows Pixie platform to heavily optimize its execution performance while maintaining expressiveness for data parsing. So Pixel programs are typically short-lived and have no implicit side effects. So as a result of that, Pixel does not have support for classes, exceptions, or other features of Python. Pixel scripts can be executed using by the Pixie platform by using the UI or CLI. And we won't install the CLI here. I'll show you it at the very end. But if you copy this command, you can run any of these scripts from the CLI. Okay, so now we're going to do a demo of modifying an existing Pixel script. So on this cluster, let me go back to PX cluster, which is our sort of main script for Pixie. So on this cluster, I have the PX sock shop demo, which many of you have probably seen before. And this microservice app has a couple of bugs. And one of them is that if you select more than 2 filters, you will not get any products back, even if there are products that should be being displayed. So let me hit this bug a few times. All right, and then we'll go back over to New Relic. So let's see if we can figure out what is causing this bug using Pixie. So given that this tab in the Sock Shop app was titled Catalog, there's a good chance it's a bug in the catalog service. So one thing to note is that these Pixel scripts are not live. So if you want to update the results, you'll need to press the run button. Okay, so let's scroll down to that services table we saw. And I'm going to sort by error rate. Okay, and you can see, ooh, maybe we need to hit the bug a few more times. This takes a second to show up. Okay, we're still not seeing an error rate here. So I'm going to click the catalog service, which will take us to the service script. And here we can see the errors they've just showed up. So we're looking at the catalog service, and we're looking at the HTTP errors graph, and we can see that we're starting to get some errors showing. So Pixie has Pixie automatically traces the full request and response bodies of application requests for the supported protocols. So let's use Pixie to see if we can find the contents of this failed HTTP request. So I'm going to go to the HTTP data script, which shows the most recent HTTP messages in the cluster. Press enter there. And again, this script is just showing all the recent clusters or all the recent requests in our cluster, but there's quite a bit of HTTP traffic in our cluster. So one thing that's really great to be able to do is to quickly modify these scripts to help you in your debugging, whatever you're trying to debug. So there's a hidden feature in Pixie, the New Relic Pixie integration, and that's the script editor. And so you can open that using Control-E on Windows or Linux, or Command-E on a Mac. So again, that's Control or Command-E, depending on your environment. And here you can see the pixel script for this script. And this pixel script is about as simple as you can get. So we're importing Pixie's module. We're creating a data frame, which again, if you've seen pandas, this is very similar to pandas, from our HTTP events table, which just has all of the HTTP requests that Pixie is automatically tracing in your cluster. We're getting the node name, which we're able to do using the UPID. And then this script has some filters for source and destination, but at the end here, and then we're returning the data frame. And this script also has a viz spec that provides the filters at the top. So that's what's going on here. So when you're looking at any of our data scripts, and we have a data script for each of the protocols that we do, it's good to be able to add filters to look for what you're looking for. So we're going to add some filters to the script under this add additional filters below. And first we want to filter, since we're looking for that bug with the catalog service, let's filter to only requests to the catalog service. So we're going to say data frame equals data frame fix.contains. And then we're going to check the destination column for the, we're going to see if it contains the catalog string. So our, the way we display destination source or pods in Pixie is to prepend the namespace. So this is the PX sock shop namespace, and the carts pod. And so we're just going to search the destination for catalog. And then the other thing, the other thing we want to look for is filter for errors. So we're going to do the response status column is greater than equal to 400. Okay, so then unfortunately the run button is behind the script editor. So you're going to need to close the script editor using the same Control-E or Command-E keyboard shortcut. And we're going to run that. And now you can see that we are just seeing the requests that have a response status of 500 and are being sent to one of the catalog pods. So if you click on any row in one of these tables, it will show you the JSON representation of this table, because this table gets a little crowded. And so so I'm going to scroll down to response body, and you can see that our error is that there's a database connection error. And to close that, you can just click the row again. And that is available over here. You can see, if you hover over the column, you can see the response body column. It's just kind of difficult to see. So that's why I like to open the row and see the JSON. Okay, so now I know from this demo's apps YAML file that the catalog surface is talking to a MySQL database. So let's go look at the MySQL data. So I'm going to go to the script drop-down menu and start typing MySQL. Click on that script. And so here we have the actual MySQL requests. So we're going to edit this script again so that we can filter to just those with an error code. And so we're going to open the script editor using Control-E or Command-E. And then I'm going to add a filter where it says add additional filters. And I'm going to make the data frame be the data frame, but filter it to just have response status equals 3. Then I'm going to close the editor and rerun. And you can see we're only getting the requests that have failed. And let's open up one of these and scroll down to the body. And if you look closely at the response body, you can see that there's a syntax error or has an extra R in it there. So now we've used Pixie to find the bug in our microservices application. But if you're interested in knowing more about how to use Pixie to debug applications, I highly recommend the talk previous today, which was the EKS talk. And the first half of the talk, they set up an EKS cluster, but the second half of the talk, they do 3 really interesting demos of like how to debug your app with Pixie. But what I was trying to mainly show you here is how easy it is to modify these scripts to filter for whatever you're looking for. So I just want to show you one other thing, which is which columns are available. So if you open up the script, it's not totally obvious what columns you can filter for. So like here we were filtering for response status, and you can see these are the columns that I'm outputting. If you want to see all of the tables that are available, you can go to the px schema script. And so this shows all of the tables that you can use with Pixie scripts and the table description, but it also shows the column names for the table. So if we scroll down to, we were in HTTP events, you can see all of the columns available to filter on. Okay, so let's hop back over to the slides. Okay, so if you want to run that demo again, this is an open source tutorial, but it basically looks almost identical to the New Relic integration of Pixie. And so this is a link to that tutorial here. Okay, so now we're going to create a custom Pixel script. And there's also a tutorial available for this on our open source docs site. And but you can bring that up now, or let me just put that in the chat. Oops, or I'll put that in the chat afterwards. Okay, so let's go back over to New Relic. Okay. All right, so there are a lot of open source scripts available in Pixie, but you might want to write your own or do more than just edit an existing script. So I'm going to show you how we can quickly write a Pixel script. And I would recommend, if you're writing your own script, that you use the CLI. The one limitation of the CLI is that it doesn't show visualizations. So I will edit a script in here. I'm just going to go back to the, or actually, you can open this script. So I will be editing and showing you how to to create a new script using this UI. But I would recommend, if you're planning on writing extensive Pixel scripts, doing it in the CLI. So I'm going to clear everything that's here, and we'll start fresh. All right, so I just want to write a really simple script in this tutorial that analyzes the volume of traffic coming in and out of each pod in your cluster. So we're going to do a script that shows per pod how many bytes were received and how many bytes were sent. So the first thing that you need to do is import Pixie's PX module. This is Pixie's main library for querying data. So we'll just do import PX. Okay, and then as I said previously, the way Pixel scripts are written is that they import a table of data into a data frame, and there are many tables of data available in Pixie, and that's what we're looking at in the schemas behind here. And so we're going to use the constats table for this, which has connection level stats information, and it has all of the communication between client and server pairs. Let's see what else it says here. Yes. All right. So we are going to make a data frame. So we're going to use px data frame. We're going to have the table be the constats table. We're going to set the start time to negative. It's a relative start time, so negative 30 seconds. And then the final thing that we need to do is display this data frame with table formatting. And so for that, we can just do px display the data frame. Okay, so I'm going to hide this script because unfortunately the run button is behind the script, and we're going to run it. And here we can see the last 30 seconds of data from this constats table. And this script has all of the tables in this constats table. So if you want, you can click this little hamburger menu over here and hide some of the columns, which can make it easier to view. So we have the timestamp, UPID, remote address, remote port, trace role, which is just whether this was traced on the client side or server side. So Pixie can trace all communication in your cluster as long as one side was within the cluster. One of the endpoints was within the cluster. So here we've got a bunch of data. And again, these columns are available in that PX schema script, PX schema script. So let's do something with this data. All right, so opening up that script editor again, let's summarize the total amount of traffic coming in and out of each pod in our cluster. So the first thing that we're going to do is add some context to transform this UPID into a pod name. So, all right, so we're gonna do diff, we're gonna create a column, and we're going to use the context function and ask it for the pod name. And then let's add service as well. Creating a service column using the context function. Okay, and then we're going to display our table again. So I'm going to hide this. We're going to see if this works. Okay, great. So now we have, let me remove some of the columns here. So we can see now we've got pod name and service name for each of the connections. Okay, so I'm going to open the script back up again. And the next thing that we want to do is group this connection data by unique pairs of pod and service columns so that we can compute the aggregate bytes were sent and received for each pair. Okay, so what we're going to do for that is, wait, so let me write this out. So we're going to group data by unique values in the pod column, and then we're going to sum the bytes sent and bytes received columns for each unique grouping. Okay, so to do that, we'll use the grouping function. So we'll do diff.group by, and then we're going to want to group by pod. Actually, we want to group by pod and service. That sounds better. And then we're going to aggregate, and we're going to create a bytes sent column. Oh, sorry, I'm having trouble typing today. Which will be a sum of the byte sent columns of all of the unique pairings in that group. And we're going to do a bytes received and again, that will be a sum. Okay. And then one fun thing we can do with Pixel is let's just force the ordering of the output columns and drop the rest of the columns. So we can do diff, and then we'll just do service, pod, bytes sent, and bytes received. Okay, and then we're displaying this in a simple table again. So let's run this and see if I've made a mistake. Okay, and yes, some of the connections are missing service. And I'm not entirely sure why. But now we have basically an overview of and you can sort by column name. So you can see the bytes sent and bytes received for each pod in your cluster. Let's filter out the rows that don't have a service identified. So okay, so that will get rid of anything or filter for only rows that have a service identified. So okay, there we go. All right, so now we've produced a script that produces a table summarizing the total amount of traffic coming in and out of each pod in our cluster for the last 30 seconds. So this is the simple script. The best way to write pixel scripts is to go look at the existing scripts. So I would highly recommend going and looking at what's out there. This script doesn't have any visualizations. Most of our other scripts have nice graphs, and you can do that using the viz spec. One limitation is we have a bug currently in which you can't update the viz spec. So we're going to get that fixed quickly, and then you'll be able to write visualizations for all of the scripts that you write. Let me see what else I've got next. Okay, so the tutorial for what I just showed you is available here on our open source site. If you're interested in learning more about Pixie, I recommend several of the following things. So definitely check out the other Nerd Day sessions, specifically the second session, which was the Amazon EKS and Pixie one. The first half of that session was setting up an EKS cluster, which you can skip if you're already if you've already done that. But the second half is showing 3 really great debugging use cases using Pixie. So I'd highly recommend that. We have one-on-one tutorials on Pixie's open source site for request tracing, continuous application profiling, service health, anything else you're interested in looking at. If you don't have a New Relic account, you can create a free account and install Pixie using this link. And if you have need any help or have any questions, you can reach out to your account team or discuss.newrelic.com. If you're creating your own pixel scripts, there's also a Pixie open source Slack. And on that Slack, you can only talk about the open source scripts, but if you're creating your own script, feel free to reach out to us if you run into any issues, and we can help you debug there as well. So now I'm going to open it up to questions, and you can ask those in the chat, or I believe you can ask them in person as well. Any questions? Okay, well, that's it for today. Feel free to reach out on Slack. My name's Hannah Troisi if you want to find me on the open source Slack. And definitely check out those other Pixie sections at the Data Nerd Days. Thanks so much, guys.